So today we're going over the last concept in the chemistry unit, okay? And that is the mole concept and the mole equation, right? So the idea of the mole is to have a unit of measurement that can communicate astronomically large numbers of particles, atoms or molecules, in a way that is more usable, okay? It works very similar to a dozen, okay? If someone says, I have a dozen eggs, how many do they have? 12. Okay, we just know that a dozen always means 12. Well, the mole works exactly the same way, except that one mole is a much bigger number than 12, okay? A mole is this many. 6.02 times 10 to the 23 atoms, molecules, particles. Okay? Is that big? It's 602 with 21 zeros behind it. They're actually not zeros, but we round it up. Okay? So it's an astronomical number, which is why we say I have 2 moles of something, rather than saying I have 1.2 times 10 to the 24 particles of this stuff, okay? Because that number is incomprehensible, okay, as a number. So we have this number called the mole that represents a certain number of particles, right? Now, the mole equation, okay, is just that. It's a simple equation, okay, that we'll use to calculate things like mass, number of moles, okay, number of particles, and things like that. Okay, so we'll go over that in a little bit. But the things we're going to go over today, what's the mole? It's a unit of measurement. It represents a certain number. Okay, the relationship between moles mass and molar mass, that is the mole equation, and we'll get to that eventually as well. Okay, and we'll use the mole equation to solve problems. So you are going to need a calculator going forward. Okay, it must be a scientific calculator going forward. Okay, it doesn't have to be a big graphing calculator, right? We don't need, one of these. Okay, I mean, if you bought one of these for math class, great, you can use that. It'll do just fine. Okay, but if you didn't buy one of those for math class and you don't want to shell out 150 or 180 bucks or whatever they are now, this I think is like $12 or $15 at like Walmart. Okay, and that will do just fine for mole equation stuff. Okay, it'll do exactly what we need, and it won't break the bank either. Okay, so by tomorrow, tomorrow is Wednesday, Thursday at the latest, okay, you must have a scientific calculator. Okay, so beg, borrow, purchase, creatively acquire, okay, a calculator by then. All right, so when we talk about materials, chemicals, things like that, okay, we can express the amount of a substance using a lot of different units, okay? We can say the mass of that material is this many grams. We could say that the volume of this material is this many liters, right? Or we could say it's this many moles, okay? And if we say it's a certain number of moles, we're basically saying that if I say I've got 2 moles, then I've got 2 times that gigantic number that we just talked about. Okay, so if I say 2 moles, it's way easier than saying whatever 2 times that number is, 1.204 times 10 to the 24. Okay, 2 moles is way easier than doing that. Agreed? It's like we say, yeah, I got 2 dozen instead of saying I have 24. Okay, so it works exactly the same way. Now, the units for moles are moles, oddly enough. Okay, so the units for a mole are moles. And because we're extraordinarily busy, we abbreviate the word mole as mole. Okay, we save countless hours of our lives by eliminating that last E. You laugh, okay, here's a statement on our society. We have an abbreviation for at. Okay? Now, drawing that, oddly enough, takes about the same amount of time as writing the full word, but that's how busy we are. Okay? All right, so 1 mole is 6.02 times 10 to the 23 particles. Now you're probably thinking, why would they pick that number? Couldn't they pick something, I don't know, easier, smaller? Well, here's the problem. Atoms are tiny. Remember that we talked about that the first day. It's like the first point of Dalton's atomic theories are tiny and indivisible. Okay, so what basically Avogadro, the guy who came up with this concept, wanted to do was find a unit, or like 12, but that would work for things that are incredibly small. Right? So he took the simplest atom, hydrogen, and because he knew it only had one proton and one electron, he could calculate what the mass of one atom would be. Now, would that be a ridiculously small number?
Yes.
Okay, so not something we can use practically, right? So he said, what I'm going to do is I'm going to use hydrogen as the exemplar, and I'm going to figure out how many hydrogen atoms there would be in 1 gram, because that's something we use all the time. Okay? Well, through his calculations, he figured out that there would be 6.02 times 10 to the 23 particles of hydrogen in 1 gram of hydrogen, which, oddly enough, is why hydrogen's atomic mass is so very close to 1 gram. Okay? The reason it's a little bit off is because there are isotopes of hydrogen that also have a neutron and they throw off the average. Okay? So that's what he discovered, and then he said, all right, that's going to be the number. Okay? Just like if I say I have 12 eggs, I have a dozen eggs, I have 12 eggs. If I say I have a dozen donuts, I have 12 donuts. It doesn't matter what I have a dozen of, I have how many? 12. So it doesn't matter what I have a mole of, I have this number, 6.02 times 10 to the 23. Okay? That is why every single element has a different atomic mass. This number is the mass of 6.02 times 10 to the 23 atoms of that element. Okay? So we call it its atomic mass, but it's actually its molar mass, or the mass of 1 mole of that material. Okay? Everybody follow me there? Okay? So that number, the atomic mass, that is the mass of this many atoms of that element. Okay? Everybody with me so far? Okay? All right. All right, so the mass of 1 mole of a substance, so the mass of 6.02 times 10 to the 23 molecules, particles, atoms, okay, is that substance's molar mass. Now, for elements, we can look those up. It's easy, okay? What's the molar mass of hydrogen? 1.01 grams per mole. What's the molar mass of oxygen? 16 grams per mole, okay? It's easy. What if I have a compound? What if somebody asked me, what's the mass of 1 mole of water?
You just add them.
Yeah. Okay, we know that water is H2O. Okay, we know that if we have 6.02 times 10 to the 23 atoms of hydrogen, okay, we know its mass would be 1.01. But in this compound, there are how many hydrogens? 2. All right, so if I want to find the mass of 1 mole of water, I take hydrogen, 1.01 grams per mole, and I multiply it by 2, because there's 2 in there, and I add it to the molar mass of oxygen, 16.00. Okay. So 2 times 1.01 is 2.02. 2.02 times, or plus 16 should be 18.02 grams per mole. Okay, so if I had 18 grams of water, it would have 6.02 times 10 to the 23 molecules of water. Okay, give you an idea, that's a little more than a teaspoon. Okay, imagine that, in a teaspoon of water, there are 6.02 times 10 to the 23 molecules of water. Boy, atoms are small, okay? But they can all fit in there. Okay, atoms are really small. Keegan, you had a question?
How did you get a 16?
Oh, 16 is the molar mass of oxygen. I just got it off the periodic table. Yeah. That's how we do it with all of them. They're all on there. All we have to do is look on the periodic table and write them out. Okay? Everybody with me on that? Okay. Then, I want to have you guys try a couple. Okay? They get progressively more involved. Okay? I want you to calculate the molar mass of these compounds. Remember, all you're doing is looking them up on the periodic table and adding them together. But keep in mind, if you got little numbers, then you got to do some multiplying. What do I do for a polyatomic ion? When I look at my periodic table, there are no molar masses for the polyatomic ions. You have to do the same thing. You have to just do them piece by piece. So how many nitrogens are in ammonium? 1. What's the molar mass of nitrogen? 14.01. You just got to do it one piece at a time. Okay? Just break it down element by element.
I just think, it's just
All right, so if we're looking at our first one here, we got sodium and we got chlorine. Is there just one of each? Okay, and is that an important thing to be able to read off of here, is how many of everything there is? Okay, so I got one sodium, so sodium is 22.99 grams per mole, plus one calcium, or one chlorine, sorry, which is 35.45 grams per mole. Okay, so if I put those two together, fire up the calculator here. All right, so 22.99 plus 35.45. All right, it's giving me 58.44 grams per mole. Okay, are units important? Yes. An answer without units is wrong. Because if you just write 58.44, I don't know whether that's 58.44 apples, oranges, elephants, old ladies with walkers. I don't know. Like, you don't put units on it, and it could be anything. So it needs to have units on it. Okay? All right, for number 2, we've got iron and bromine. So iron, 58.55. Correct me if I'm wrong, guys, going off my memory here. Okay, and bromine, 79.90. Okay, anything I do wrong there?
Yeah.
What did I do wrong?
Iron. Did multiply by 3.
I didn't multiply the bromine by 3, right? There are 3 bromines in here, so. And it's 58.55 plus 3 times 79.90. Okay, so 58.55 plus 79.9 times 3. Whoops, that's got to be a plus.
It's 55.85.
Oh, I have the numbers backwards. 55.85. That's better. Okay, plus, also better. Okay. 295.55 grams per mole. Okay, questions on that one? How many people live down number 3? Okay, let's look at number 3. All right, we got diphosphorus pentaoxide. So phosphorus, 32.07, 30.97. Let's get sulfur and phosphorus next time. Okay. 30.97. There are 2 of those, so 2 times that, plus 5 times 16.00, because there are 5 oxygens. All right, so 2 times 30.97 plus 16 times 5. Okay, 141.94. grams per mole. Okay, anybody want some more time on 4 and 5? Everybody good for 4 and 5? Okay. When brackets come into play, that's when things get real. Okay, so how many nitrogen are in compound number 4?
2.
2. okay? Because the brackets are around the ammonium, and that means that there are 2 ammoniums, so that means there are 2 nitrogens. So 14.01 times 2. All right, plus, how many hydrogens are there? 8. 4 times 2 is 8, right? So we got 8 times 1.01. All right, how many sulfur are there? 1. Okay, how many oxygen are there? 4. Okay, we punch all of that in, so we got 28.02, that's the 2 nitrogens. Okay, plus 8.08, that's the 8 nitrogens, plus 32.07, plus 16 times 4. 132.17 grams per mole. Questions on number 4? Okay, number 5, I don't remember what scandium is. 44.96. Okay, how many scandium are there?
1, 2.
2. 44.96, right? Okay, so there's my scandiums. Plus, how many carbons? 3. Okay, so 12.01 times 3 plus how many oxygen?
9.
9. All right, so 44.96 times 2 plus 12.01 times 3 plus 16 times 9. Okay, 269.95 grams per mole. Okay. How are we feeling about calculating molar mass? Okay, I mean, you're just taking the numbers off of there and putting them together. It's not rocket science, okay? It takes a little practice, but it's nothing terribly complex. All right? Okay, what do we got here for time? Okay, I'm gonna give you guys about a 5-minute break before we move on to the actual mole equation itself. Okay, so 9:30, we're back at this, so you can visit, okay, for 5 minutes. Okay, so something we need to understand about the mole, okay, is that it's also part of balancing reactions. Okay, we could look at a reaction like this one here, where we have N2 plus 3 H2 gives 2 NH3s. Okay, now we could look at that and say, okay, this reaction means that 1 nitrogen molecule reacts with 3 hydrogen molecules to produce 2 molecules of nitrogen trihydride. Would we even notice that reaction if we were talking about those amounts? No. Okay, that would be such an incredibly small amount that we'd never even know that that reaction happened. All right. While it's true, okay, that's exactly how it would go. We would definitely deal with this in bigger amounts. Okay, it would also mean, or could also mean, that I had 1 mole of nitrogen gas, and that I had 3 moles of hydrogen gas, and that when I reacted the 2 of them, I got 2 moles of nitrogen trihydride. Okay, that would be another way to look at it. Or I could look at it from a mass point of view. I could say that there are 28.02 grams of nitrogen, and that there are 6.06 grams of hydrogen. Okay, and that would make 34.08 grams of nitrogen trihydride. Okay, are all of the ways I express that reaction true? Absolutely. Okay, so just know that when we balance a reaction, more often than not, we mean that 1 mole of nitrogen gas, 3 moles of hydrogen gas gave 2 moles of nitrogen trihydride. Okay, that's usually what those balancing numbers mean. Okay, now this is Avogadro. I think his nickname must have been the mole. Yeah? That's where he got the idea for the name, I think. Cause you know, if you ever seen the mole, they kind of have those like sunken eyes like that. And, yeah, and the cut of his suit makes him look like he has no shoulders. kind of strange. Okay. So, at this point, I always play something because it's funny and I always laugh at it. All right, so, using the mole equation. Okay, so the mole equation goes like this. Okay, N equals little m over big M. So little lowercase m over capital M. Okay, because, well, reasons. There's only, 26 letters in the English language, so we should use the same letter twice in a simple 3-variable formula. Oh, and the other letter we should use is the one that sounds like the one we doubled up on, n equals m over m.
And
Okay?
looks like.
And looks like. So, yeah, chemists. So, here's what we need to know. Okay, n is the number of moles. And when I write that, I don't mean hashtag moles. Okay, I mean number of moles. That used to mean number. It still does. Okay, little m is the mass, and that is always in grams. Okay, and big M is molar mass, that thing we just learned how to calculate. Okay, and that is in grams per mole. Right, so the way the formula works is I would take a mass in grams and I would divide it by a molar mass in grams per mole. Okay, what would cancel here? The grams, and I'd be left with moles, which is what I'm looking for in the formula. N's units would be moles because it's the number of moles. Okay? Now, you are going to be required to do algebra and manipulate this formula. That is, solve for things other than n. You can do that using algebra, not a triangle. So help me God, if I see a triangle on any of your papers, I will absolutely lose it. Okay, I don't know who teaches you that, but they are crippling you in terms of your math ability. You do not need a triangle to do algebra, okay? So if you've been using a triangle up until now, your life is about to change for the better. Okay, it's going to be sunshine and rainbows and unicorn farts. Okay, like for the rest of your life, because you're going to be able to do algebra the real way. Okay, because here's the problem, guys. In this course, we're going to use formulas like this. Got a triangle for that?
Square.
Not even that'll work. It's got an addition-subtraction operation in it. Triangles only work for 3-variable formulas, maybe a 4, as long as everything is being multiplied. So, or this formula here, kinetic energy equals 1/2 times mass times velocity squared. So you have a triangle with a little square on the side?
Yep.
Okay, or how about this one? I don't know too many formulas that do a square root for you, or triangles that do a square root. I don't know, maybe like a rhombus? Probably not. Okay, because the fact of the matter is somebody taught you a triangle because it was the easiest way to get you to be able to do formulas when you were in junior high. It was a disservice, okay, because you probably got reliant on it and didn't learn how to do algebra. You need to know how to do algebra. Okay? It doesn't matter which science you do, even biology, there's going to be formulas. You do Hardy-Weinberg ecology stuff in Bio 30, and you'll have to be able to do algebra for that. Now, here's the good news. Algebra is not hard. Okay? Algebra is not hard at all. Okay? There are simply 3 rules for algebra, which I would like you to write down right now. Okay? These are the 3 rules of algebra. They are immutable. And if you follow them, you will do just fine. These 3 rules got me through university physics. It didn't help me at all in calculus.
Can I put it on my periodic table?
No, don't write it on your periodic table. Put it in your notes. Okay? I'll give you a few minutes on that one. Okay, so the 3 rules of algebra go as follows. Okay, the first rule says that if I want to move something, I want to move a variable from one side of the equal sign to the other, I need to perform the opposite operation. So if I was adding that variable, I would subtract it from both sides. If I was dividing that, I would multiply it over to both sides. I would do the opposite. Okay. The second rule is the golden rule of algebra. What I do to one, I do to the other. Okay. So if I multiply it on one side, I need to multiply it on the other. You can do whatever you want to an equation, as long as you do it to both sides. Okay. The third rule of algebra actually won't apply to the mole equation. It's too simple. Okay, but some of the other equations we deal with this one will be necessary, and that is move what is not, in quotations, attached to what you are looking for first, okay, or what needs to be isolated first, and I'll explain what I mean by that in just a minute. Okay, so let's look at an equation, okay, like this one here, that you're going to use in math. Okay, if you're in math this semester, you're going to get to this probably pretty quickly. All right, so y equals m times x plus b. Let's say I wanted to solve for m. What should I move first?
B.
B. B is not attached to m. X is attached to m, but b is not. All right, so I would subtract b. I'm just going to rewrite the equation over here, guys. Y equals m times x plus b. I would subtract b. Well, b minus b is 0, so that takes care of that. It's gone from that side. Okay, but what I do to one side, I have to do to the other. So y minus b. So now I've subtracted b from both sides. It made it disappear on that side, and it ended up being y minus b on the other. All right, I'm trying to isolate m. Right now I'm multiplying m by x. So I need to move x. What do? Joe?
You divide by x.
I divide both sides by x. I do the opposite. Okay, the opposite of multiply is divide. What's x divided by x?
0. 1.
1. Okay, x divided by x is 1. What's m times 1? M. Perfect. So that makes sure that we have eliminated x from that side by essentially making it 1. Okay, and then I got to do it to the other side. Y minus b over m. Or sorry, over x. I put m over there. Over x. Y minus b divided by x. Now I've solved for m. Okay, is that very hard?
No.
Did I just have to follow those 3 rules?
Yeah.
Triangle.
Okay, those rules are infallible. Okay, absolutely infallible. So, if I am using the mole equation, okay, oh, I had it there. Okay, so we're going to work with this here. I'm going to move. Oh, crap. I'm going to move that back over. Okay, so this is how the mole equation starts out. N equals little m over big M. All right, so it already solves for the number of moles. I want to solve for mass, for little m. What do I have to do to get rid of big M?
Times.
Multiply, yeah. Okay, all I have to do is multiply both sides by it. So if I went like this, okay, and I multiplied both sides by m, okay, I'd have a big M on the top and a big M on the bottom. M over m is
M.
1. Okay, so that means it's gone. Okay, so it would be gone from there. And I would multiply the other side by it. Okay, so it would come over here. M times n equals m. Now, if you're ever in doubt about your algebra, you can always check it by looking at your units. Okay, the units for big M are grams per mole. Okay, and I'm multiplying that by n, whose units are moles. Okay, do I have moles on the top and moles on the bottom?
Mm-hmm.
Boom, what am I left with?
Grams.
Grams, that's the units for mass. I probably did right then.
Graham cracker.
Okay, you can always do it that way. Everybody with me there?
Mm-hmm.
Okay, so we don't need triangles.
Oh.
Not ever again. Ever
Is the
again.
triangle? What even is the triangle?
I'm not, if you don't know what it is, good. You're better off not knowing. Enjoy the mystery. Okay. There are only 4 ways I can ask you a mole equation calculation problem. All right? What we're going to do for probably the next 4 days is go over mole equation problems. And the start of each class, I will go over another example of each one of the 4. Okay, so by the end of this, you'll have 4 examples of each way I can ask a mole equation question in your notes. So to that end, please write down the question on the board, and we're going to go through it. Okay, so this is mole equation type 1. It's the easiest mole equation problem. Now, when you do a mole equation problem, okay, you're going to get marks for your work. So for each step. So what I'm going to do is I'm going to go through all the steps that I would expect you to show in order to get full marks. Okay? The first step in any problem solving, be it mole equation or any of the problems we would do in physics, okay, is to write down what we call our givens. That is, what are the variables the question told you? All right? So, question's asking how many moles? What are they asking me to find?
Moles.
Moles, which is what part of the mole equation?
Big.
Small n. N is the number of moles. Okay? That's what they're asking me to find. And no, the thing that you're solving for that actually starts with M is the thing that starts with N because reasons. Okay? So, the next thing they tell me is that it's calcium chloride. What can that help me find? The molar mass, right? So I can right now go, okay, big M is going to be, and I'm just going to write down that it's calcium chloride. So that's going to be 40.98?
08.
08, 40.08. 40.08, okay, plus 35.45 times 2. That should be 110.98 if my mental math is right.
Yep.
Okay. All right, so now I've got my molar mass, and what's the other thing they told me?
90 grams.
90 grams, which is what part of the mole equation?
Smaller.
Small m, right. All right, you would get 1 mark for that. Okay, calculating your molar mass and writing down your givens is 1 mark.
No.
Now, the next mark you would get is for identifying this as a mole equation problem and writing the formula that you would use. Okay. Now, because you don't need to manipulate for this question, it's already set up to solve for n, okay, you don't get any marks for the next step, which is just plugging in your numbers. 90 grams, big or little m, divided by 110.98 grams per mole, big M. All right, and if I plug those in, 90 divided by 110.98. All right, so that is 0.81 moles. Is it okay that I got a decimal?
Yes.
Yeah, I have less than a mole, right? 1 mole is 110.98 grams. I only have 90 grams. I don't have a mole. I have less than that. Okay, so 0.81 moles.
So we're-
For our purposes, 2 decimal places will be sufficient.
Okay.
Did I read mine?
Yeah.
Yeah. Okay, that would be your 3rd and final mark. Okay, so that would be a 3-mark question. Okay, questions on mole equation type 1? Okay, we're going to get through mole equation type 2, and then we'll quit for today. Okay? All right, question number 2. Write that one down, guys. We're looking in this one for the mass of 4.5 moles of magnesium bromide. Okay, so for this one, right, we are going to write down our givens again. They're asking us to find the mass. So what are we looking for?
Mass.
Which is small m, right? All right, and they tell us 4.5 moles. That would be
N.
N, right? And they say it's magnesium bromide, but this time they put it in words. Does that make the question just a little bit harder? Yeah, because if you forget to drop and swap this, you'll get it wrong. Okay, so big M is MgBr2. Okay, so that's going to be 39.10. Is that right? No, 24.31.
Yep.
24. Potassium's 24.31. Okay, plus bromine, which is 79.9, and there are 2 of them, so times 2. Not going to mental math that one. 24.31 plus 79.9 times 2. Okay, 184.11 grams per mole. All right, 1 mark for my givens. Okay. Then 1 mark for identifying it as a mole equation question, writing down the mole equation. Now in this one, I do have to do some algebra. I'm looking for little m. So what do I have to do with big M?
Multiply big M.
Right, multiply both sides by big M. Sorry, that would be a mark, okay, and then showing your work here, so multiply both sides by big M. Okay, you'd get a mark for that, okay, and or plugging in your numbers. So that would be 184.11 times 4.5, big M times N. Okay, so that would be your 3rd mark, and then your 4th mark would be for your final answer. So that number there, that's the mass of 1 mole times 4.5 moles. Okay, 828.50. What are my units on that?
Grams.
Yes, grams, sorry. I put N there, grams. Okay, 4 marks for that one. Okay, tomorrow we will go over mole equation types 3 and 4. They have extra steps involving Avogadro's number. That's 6.02 times 10 to the 23. We're going to start using that with mole equation types 3 and 4 tomorrow. Okay, this week's quiz on Friday will be on the mole equation because we'll have worked on it for 3 straight days and you'll be good at it by then. Okay, so Friday's quiz will be on the mole equation. I'll put up the pertinent quizzes here in a minute.